from Department of Artificial Intelligence and Data Science. Today we are going to see about half adder and full adder. Half adder. Combinational design procedure. Half adder is a combinational arithmetic circuit that adds two numbers and produces a sum and carry as an output. If A and B are the inputs, then sum and carry are the outputs. This is the block diagram of an half adder which contains two inputs and two outputs. The main objective of an half adder is it is designed to add a two single bit. It is a basic building block for addition of two single bit numbers. The input and output variables of an half adder is the input variables are A and B and the output variables are sum and carry. This is the truth table of an half adder. The Boolean expression using K-map is placed for sum and carry using an inputs. This is the circuit diagram of an half adder. Two input AND gate, XOR gate, IC trainer kit and patch. Let's enter into a demo. For that, we need two toggle switches here, and we need one XOR gate and one AND gate here. As usual, and output controls are used in every circuit. For better understanding, let's label the following using an label box. The first switch is named as A and the second switch is named as B, and the first output is named as sum and the second output is named as carry. Let's start the connections. First input is directly connected to the XOR gate's first input, and it is also connected with AND gate's first input. Now B is connected to the AND gate's second input and also with XOR gate's second input. Now it is directly connected with the sum and carry. We can use an truth table values to check whether it is correct or not. When both are 0, the output will be 0. When the second input is 1, the sum is 1. When the first input is 1, the sum is 1. When both the inputs are 1, then the carry is 1. This is the circuit demo of half adder circuit. Now we can start with full adder. Combinational design procedure. The output S is an XOR between the input A and the half adder sum output B. The C out will be true only if any of the two inputs of the three are high or at logic 1. The output S will be obtained. This is the actual procedure what we need to follow in the circuit demo. This is the block diagram of full adder circuit. The main objectives of an full adder is little more difficult to implement than half adder. The main difference between a half adder and a full adder is that the full adder has 3 inputs and 2 outputs. The input and output variable of an full adder is the first two inputs A and B, and the third input carry on is C in. These are the 3 inputs of an full adder, and the output is C out, is an output of an full adder. This is the truth table of an full adder circuit. Boolean expression is used using K-map for sum and carry for better understanding. This is the circuit design of an full adder. To make a circuit, these are the components required to make an full adder circuit. Let's take a demo. For this, we need 3 toggle switches here, and 2 XOR gates, and 2 AND gates. And 1 OR gate. And we require output controls here. Let's label the following using an label box. The first switch is named as A, and the second switch is named as B, and the third switch is named as CIN. The outputs, the first output is named as sum, and the second output is named as carry. Let's start connecting this. The first switch is connected directly to the first XOR gate's first input, and also with AND gate's second input. And the second switch is connected to the first XOR gate's second input, and also with second AND gate's first input. Now, the third switch is connected to the second XOR gate's second input, and the output of first XOR gate is connected to the first input of the second XOR gate. Now, it is also connected with first AND gate's second input. The third switch is also connected to the first AND gate first input. Now, both the AND gates output are connected with the OR gates first and second input. Now, the output of the XOR gate is connected to the sum, and output of OR gate is connected to the carry. By applying the values of truth table, we can identify whether it is correct or not. When all the inputs are 0, the output will be 0. When the third input is 1, the sum will be 1. When the second input is 1, the sum will be 1. When both second and third input is 1, the carry will be 1. When the first input is 1, the sum will be 1 in the output. When 1 and the third input is 1, then the carry will be 1. Then first and second input is 1, then the carry will be 1. When first, second and third inputs are 1, the sum and carry output will be 1. These are explained in the truth table which I attached a PPT. So, these are called as an full adder. Thank you.